Welcome to the fascinating world of algebra. Today we're going to explore one-step equations, which are your gateway to understanding more complex mathematical concepts. Think of these equations as the foundation stones that will support everything you learn in algebra. So what exactly is a one-step equation? It's an algebraic equation that requires only one mathematical operation to solve for the unknown variable. The key word here is one. We only need to perform a single step to find our answer. Here are four examples of one-step equations. Notice how each equation involves just one operation with our variable. We have addition, subtraction, multiplication, and division. Each of these can be solved with exactly one step. Let me show you what we mean by one step. Take this equation, x plus 7 equals 15. To solve this, we only need to perform one operation, subtract 7 from both sides. That's it. One step and we have our answer, x equals 8. One-step equations are the fundamental building blocks of algebra. Just like a house needs a strong foundation, your algebra skills need this solid base. Master one-step equations and you'll be ready to tackle two-step equations, multi-step equations, and eventually much more complex mathematical problems. In this comprehensive lesson, you'll learn how to isolate variables, understand inverse operations, solve equations involving addition, subtraction, multiplication, and division, and most importantly, how to check that your solutions are correct. By the end, you'll have the confidence and skills to tackle any one-step equation that comes your way. Are you ready to begin your algebra journey? Remember, every expert was once a beginner, and every complex problem starts with understanding the basics. One-step equations are your first step toward mathematical mastery. When we solve a one-step equation, we have one primary goal: to isolate the variable. But what exactly does this mean? Let's look at some equations where the variable is not isolated. In these examples, the variable is mixed up with other numbers. Notice that in each equation, the variable is combined with another number. In the first equation, x is added to 5. In the second, y is multiplied by 3. These variables are not isolated. Now let's see what it looks like when variables are properly isolated. This is our goal. Perfect. Now each variable stands alone on the left side of the equation. The variable has a coefficient of 1, meaning it's just x, not 2x or 3x. This is what we mean by isolating the variable. But how do we get from the non-isolated form to the isolated form? The key is understanding that an equation is like a balanced scale. Just like a balanced scale, whatever we do to one side of an equation, we must do to the other side to keep it balanced. This is the fundamental rule of algebra. To isolate x, we need to remove the 5 that's being added to it. We do this by subtracting 5 from both sides. Watch what happens. Excellent. Now x is isolated. We've successfully used inverse operations to solve the equation while keeping it balanced. This is the core strategy for solving all one-step equations. Remember, isolating the variable means getting it alone on one side with a coefficient of 1. We achieve this using inverse operations while maintaining the balance of the equation. This is the foundation of solving one-step equations. Now that we understand our goal of isolating the variable, we need to learn about the tools that help us achieve this goal. Inverse operations. Inverse operations are mathematical operations that undo each other. Addition and subtraction are inverse operations. This means they undo each other. If you add 3 to 5 to get 8, you can subtract 3 from 8 to get back to 5. Think of an equation like a balance scale. Both sides must remain equal. Whatever operation you perform on one side of the equation, you must perform the same operation on the other side to maintain balance. When we have an equation like x plus 5 equals 12, we need to eliminate the 5 that's being added to x. Since addition and subtraction are inverse operations, we subtract 5 from both sides. When we have an equation like y minus 3 equals 10, we need to eliminate the 3 that's being subtracted from y. Since subtraction and addition are inverse operations, we add 3 to both sides. Remember these key principles. For addition equations, subtract the same number from both sides. For subtraction equations, add the same number to both sides. The most important rule is to always maintain balance by performing the same operation on both sides of the equation. Now we move on to inverse operations involving multiplication and division. These operations follow the same fundamental principle of maintaining balance, but they work in a different way than addition and subtraction. When we have an equation with multiplication, we use division as the inverse operation. When we have division, we use multiplication as the inverse operation. The key is always doing the same operation to both sides of the equation. Let's start with multiplication equations. Consider the equation 4z equals 20. Here, the variable z is being multiplied by 4. To isolate z, we need to undo this multiplication. Since z is multiplied by 4, we use the inverse operation, which is division. We divide both sides by 4. This maintains the balance of the equation while isolating our variable. When we divide 4z by 4, the 4's cancel out, leaving us with just z. On the right side, 20 divided by 4 equals 5. Therefore, z equals 5. Now let's look at division equations. Consider the equation a divided by 2 equals 6. Here, the variable a is being divided by 2. To isolate a, we need to undo this division. Since a is divided by 2, we use the inverse operation, which is multiplication. We multiply both sides by 2. This undoes the division and isolates our variable a. When we multiply a divided by 2, the 2's cancel out, leaving us with just a. On the right side, 2 times 6 equals 12. Therefore, a equals 12. Let's visualize why these inverse operations work using a balance scale. An equation is like a balance scale. Whatever we do to one side, we must do to the other side to maintain balance. When we divide both sides by 4, we're performing the same operation on both sides. The scale remains balanced, but now we have isolated our variable. This is the fundamental principle behind all equation solving. Remember these key points. Multiplication and division are inverse operations. When a variable is multiplied by a number, divide both sides by that number. When a variable is divided by a number, multiply both sides by that number. Always perform the same operation on both sides to maintain equality. These inverse operations for multiplication and division are fundamental tools in algebra. Master these concepts, and you'll be ready to solve any one-step equation involving these operations. Now we're ready to solve our first one-step equation. We have x plus 8 equals 15. This is a perfect example to demonstrate the process we've learned. Our goal is clear. We need to find the value of x. This means we want to isolate x on one side of the equation so that x equals some number. Let's think about our strategy. We can see that 8 is being added to x. To isolate x, we need to undo this addition by using the inverse operation, which is subtraction. Think of an equation like a balance scale. Both sides must remain equal. Whatever we do to one side, we must do to the other side to maintain this balance. Now let's solve this step by step. We'll subtract 8 from both sides of the equation. We subtract 8 from the left side, and we must also subtract 8 from the right side. This keeps our equation balanced. Now we simplify both sides. On the left side, x plus 8 minus 8 equals x plus 0, which is just x. On the right side, 15 minus 8 equals 7. Excellent, we have found our solution, x equals 7. Let's emphasize this important result. This example perfectly demonstrates the key concept of inverse operations. Since 8 was added to x, we use subtraction to undo that operation. Remember, whatever we do to one side of the equation, we must do to the other side to maintain balance. In our next example, we'll see how this same principle applies to different types of one-step equations. The process remains the same. Identify the operation, apply the inverse, and maintain balance. Now let's work through our second example, which involves a multiplication equation. This will help us practice using division as the inverse operation. Here's our equation, 3y equals 21. Take a moment to examine this equation and think about what operation is being performed on the variable y. In this equation, we can see that y is being multiplied by 3. The coefficient 3 in front of the variable y indicates multiplication. Since y is being multiplied by 3, we need to use the inverse operation to isolate y. The inverse of multiplication is division, so we'll divide both sides by 3. Step 1, we divide both sides by 3. This gives us 3y divided by 3 equals 21 divided by 3. Remember, whatever we do to one side of the equation, we must do to the other side to maintain balance. Step 2, let's simplify the left side. When we have 3y divided by 3, The 3's cancel out, leaving us with just y. This is exactly what we want, the variable isolated by itself. Step 3. Now we calculate the right side. 21 divided by 3 equals 7. We can verify this by thinking, what number times 3 gives us 21? The answer is 7. Our final answer is y equals 7. This means that when y is 7, the original equation 3y equals 21 is true, because 3 times 7 does indeed equal 21. We can verify our answer by substituting 7 back into the original equation. 3 times 7 equals 21, which confirms our solution is correct. Remember this key concept. When a variable is multiplied by a number, we divide both sides by that same number to isolate the variable. This is the fundamental principle of using inverse operations in algebra. Excellent work! You've now successfully solved a multiplication equation using division. This skill will be essential as we move on to more complex algebraic problems. Now that we've learned how to solve one-step equations, there's one crucial final step that many students skip: checking your solution. This verification process is essential for building confidence and catching any errors you might have made. Checking your solution serves several important purposes. First, it confirms that your answer is actually correct. Second, it helps you catch any calculation errors you might have made along the way. Third, it builds your confidence in problem solving. And finally, it develops good mathematical habits that will serve you well in more advanced topics. The substitution process follows 4 simple steps. First, take the solution value you found. Second, substitute this value back into the original equation in place of the variable. Third, simplify both sides of the equation by performing the arithmetic. Finally, check if both sides are equal. If they are, your solution is correct. Let's work through our first example. We have the equation x plus 5 equals 12, and we found that x equals 7. Now we need to check if this solution is correct by substituting 7 back into the original equation. We substitute 7 in place of x in the original equation. This gives us 7 plus 5 equals 12. Notice how we've replaced the variable x with our solution value 7. Now we simplify the left side. 7 plus 5 equals 12. We get 12 equals 12, which is a true statement. This confirms that our solution x equals 7 is correct. For our second example, we have 3y equals 21, and we found that y equals 7. Let's check this solution using the same substitution process. We substitute 7 for y, giving us 3 times 7 equals 21. Notice the parentheses around the 7 to show the multiplication clearly. Simplifying the left side, 3 times 7 equals 21. We get 21 equals 21, which is true. Our solution y equals 7 is verified as correct. For our third example, let's see what happens when we check an incorrect solution. We have z minus 4 equals 9, but suppose we incorrectly found z equals 5. Let's check this solution to see if our verification process catches the error. We substitute 5 for z, giving us 5 minus 4 equals 9. Simplifying the left side, 5 minus 4 equals 1. We get 1 equals 9, which is clearly false. This tells us that our solution z equals 5 is incorrect, and we need to go back and solve the equation again. The correct solution is z equals 13. This example shows how checking your solution is a powerful tool for catching errors and ensuring accuracy. Here are some important tips for checking your solutions effectively. Always substitute back into the original equation, not any intermediate steps. Show your substitution work clearly so you can follow your reasoning. Simplify step by step to avoid arithmetic errors. If your check fails, go back and resolve the problem. Finally, make checking a habit for all equations you solve. This practice will serve you well throughout your mathematical journey and help you become a more confident problem solver. Remember, a solution isn't complete until it's verified. Checking your work is not just a good habit, it's an essential part of the problem-solving process that will make you a stronger mathematician.